I'm going to demonstrate how Unity can communicate with a platform which is used for sound synthesis, and we will dynamically create the soundtrack of the video game, of a very basic video game that I just have designed in the Unity video game engine. And the both scripts are very minimal, and the reason for these scripts are to show how we can make implement and make practice of the industry nuance in video game sound design, named as procedural sound design for a video game. And this is a practice that it's becoming kind of a best practice when it comes to designing dynamically the soundtrack, or dynamically creating the sound effects of a video game instead of loading audio assets to the video game engine, which been the practice for many years now. And also following this way and creating the sound design and the effects and the soundtrack using such implementation, like having this minimal script here, which makes basic sounds, but of course you can create your own more complicated scripts. It has smaller audio footprint in the video game, and it can be something very minimal as this one, or it can be scaled up later. It can be changed according to the needs of the sound that is required by the video game. And also it's technologically optimized using less resources, and Unity video game engine can run pure data, which is something similar to MaxMSP, but it's the open source version of MaxMSP. So it means it's free and can be opened in Unity, and in this way you can create your own patches and export it, the whole game with the procedural and generative synthesis patch embedded in the game. So let's see how I going to create this procedural and generative sound for this basic video game that I created in Unity. So first I'm going to run this script in SuperCollider. We'll see in the post window that it's loading, and we see that we're using the Modio driver. The moment I fire up this basic script, I'm kind of running a very little minimalistic arpeggiator kind of video game. So now I'm gonna open the video game like previously, and start again. So every time I move this little sphere and I'm kind of pumping this sphere into these elements, you hear something that kind of gives you a cue that something is being completed in a way. So the sound is getting SuperCollider dynamically, and because there are some random operators every time I am leading to that, have a different. So let's go back to SuperCollider and let's see what happened in the post window. In the post window, I had these messages every time I received this peak trig, which is peak trigger with a value of 1, between 0 and 1. So I had this used as a trigger. Every time I received 1, it would trigger this very basic algorithm which embedded a LFSO oscillator, a SAW oscillator. And as I was saying, this dynamic creation of the SAW oscillation, it embedded a random operator. So every time it changed, it wasn't the same. In order to create some variation, some indeterministic outcome of the sound. And the same for when I received the message win, win, which means it was the end of the game. So that was triggered by another little algorithm here, which again, it has a saw oscillator here, and here it embedded a ramp line. Ramp line means it will go from a given minimum value to a given maximum value in a n time, in a fixed time. N time means can be anything. So with random, again, controlling the phase of the saw oscillator, and both of them, they were controlled by an envelope because we wanted to have something which changes but also stops, and it's not going to be like a drone in the entire game, because that would also conflict with this little arpeggiator. So this is very basic, but actually it shows what is known right now as a best practice or as a research in the industry of video game procedural sound design. And of course, this is very minimal. It's just to show how the idea can be implemented. And also, it doesn't have to be with scripting languages. It can be also with other synthesizers, like any software synthesizer you're using. So, but because scripting languages are having a very little footprint, I think they're much more light and much more scalable to use with. So that's a little bit about generative audio sound design in video games.